Okay, hello, this is Dr. Hanaa Assil, and this is the second lesson in the IGCSE Edexcel Chemistry. In this lesson, we're going to talk about the questions that we had on Chapter 1. So, after the last lesson, you should have gone to the questions that are uploaded from the PDF version on the website. And you should have tried these questions, and now we will discuss the answers that are supposed to be given to these questions. So let's go to the first question. So if you have the PDF version of the questions, are we ready? The first question there is, complete the diagram to show the arrangement of particles in a liquid. And he says that one particle has been drawn for you. You should realize he's asking us to draw the diagram of what? He's asking us to draw the diagram of a liquid. And you should remember how are particles in a liquid arranged. They are arranged, we said, near to each other in clusters. So you need to fill up that box, and your diagram should look something like this, so that they're near to each other. Some of them are touching, some of them are not touching. They are not in any particular order, so don't put them in regular rows. So your diagram should look something like this. Okay, the next question says, much more oxygen can be stored in the tank when oxygen is a liquid rather than a gas. Now give a reason for this in terms of arrangement of particles. So he's saying that if I have a tank and I want to fill it with oxygen, I can put in more oxygen particles if the oxygen is in form of a liquid rather than a gas. Do we remember why this is? Remember that we said particles in a liquid are more closely packed, so more particles can be placed in a certain volume. Remember that you're comparing between liquid and gas, so you have to have some sort of comparison. So either you say in liquids they are nearer to each other than in gases, or in liquids they are more closely packed, so you can put in more particles that in a certain volume. Okay, this was another question which we saw during the lesson. The arrow of X indicates a change from liquid to gas. Remember that the change from liquid to gas, you can either say boiling or you can say evaporation. That would be correct also. Now Y is going from gas to liquid, so that should be condensing. And Z is going from liquid to solid, so that is freezing. Did you get the right answer? You should have gotten the right answer. The next question says, which statement best describes the movement of particles in a gas? So you need to choose one of these questions. One of these answers. The particles vibrate about fixed positions. Remember, he's talking about a gas. Is that correct with respect to a gas? No, fixed positions. We talk about vibrating fixed positions if we're talking about a solid, not a gas. Particles slide past each other, or move around each other. That applies to what? It applies to liquids, not gases. Particles move freely. Now that's supposed to be our answer, because particles in a gas move freely. Particles do not move at all. That is not right, because we never say that particles do not move at all. So your answer is C. Remember that in Edexcel, you're supposed to put, for the multiple choice questions that have a box next to it, you're supposed to put an X within that box. A student investigated what happened when a sample of wax was heated using a Bunsen burner. He set up the apparatus as shown. The student heated the solid wax strongly with a Bunsen burner until it turned into a liquid. Give the name of the process that occurs when a solid turns into a liquid. You should remember that when a solid turns into a liquid, it's called melting. Explain one change needed to make the experiment safer. Now this type of experiments, we need to think about a certain safety precaution. If we're heating solid wax in a test tube, what do you think would be a safe way of heating it so that it doesn't splash around? we should heat in a hot water bath. This will prevent the wax from boiling over or splashing out. The next question says, describe the changes in arrangement, movement, and energy of the particles when liquid wax cools to become a solid. So we're talking about liquid cooling to become a solid. That is sort of freezing. What happens to the arrangement of the particles, the movement of the particles, and the energy of the particles? Liquid to solid. You have to say what is happening is, first of all, you're cooling it, so you have to say that particles lose kinetic energy. When you cool something, particles lose kinetic energy. Now, when they lose kinetic energy, that means the particles will start to move slower. When they move slower, then they come closer to each other in that order. And when they come closer to each other, they will become a solid, and you should know that that means that they will become a regular arrangement in rows. So in that case, we have talked about the energy, that they will have less energy. We have talked about the movement, that they will move slower. And we have talked about the arrangement, that they will come closer and become regular arrangements in rows. Okay, the next question was asking, a crystal of copper chloride was placed in a beaker containing water. It was left for several days. Explain how the appearance of the liquid in the beaker changes after several days. So, copper chloride, if you don't know, you should know that copper is a transition metal. A compound of a transition metal is colored. So, copper chloride crystal actually has a green color. So what would happen to the water when you put a crystal of copper chloride at the bottom of the beaker? You should realize that the color will spread throughout the liquid by diffusion. We have an open-ended tube with cotton wool on one end containing concentrated hydrochloric acid, and on the other end it contains concentrated ammonia solution. After a few minutes, a white solid appears inside the tube. Identify the white solid. When ammonia reacts with hydrochloric acid, the white solid that forms is called ammonium chloride. So, what does the diagram show? So, what does the diagram show about the speed of the ammonia molecules compared to the speed of the hydrogen chloride molecules? Remember that we said if the white solid is formed nearer to the hydrochloric acid, so which one is diffusing faster? You should realize that that means that the ammonia molecules diffuse faster. Now, the next part says, state the main hazard when using concentrated hydrochloric acid in the experiment. Remember that hazard, what does hazard mean? Hazard means a danger, something dangerous about the experiment. So, remember that if we're using concentrated acid in general, concentrated acid is corrosive. Corrosive means it's harmful to the skin. And that means that my precaution should be, I should wear gloves, eye goggles to protect the skin and the eyes from damage. Are we okay? Now he's saying melting point and boiling point of 4 substances are shown. Which substance is a liquid at room temperature? Which substance is a liquid at 100 degrees? 100 degrees. So if we look at the melting point and boiling points that are given for the substances, he wants something that's a liquid at 100, and you should remember that a liquid at 100 means that the melting point should be below 100 and the boiling point should be above 100. So A, both of them are too low. B, at 100 degrees, it has already boiled because the boiling point is lower than 100 degrees. So that's not the answer. C would be my correct answer because the melting point is below 100 and the boiling point is above 100. So it is a liquid at these temperatures. The other one, the temperatures are very high. The last answer, the question, the melting point and boiling point are very high, and that means that at 100 I have not yet reached the melting point, so it would be a solid. Are we okay with all of this? Now, the next question says melting points of 3 related compounds are given. The boiling point of all these compounds is above 100. So the melting points are 32, 8, and 63, and all of them have a boiling point above 100. Use the grid first of all to draw a bar chart. You should know how to draw a bar chart. So this would be a bar chart that you should have. Are we okay with drawing a bar chart? Now the next question says melting points of, okay, these are the same melting point and boiling point, and he's saying give the physical state of each acid at room temperature. So capric acid, its melting point is 32, boiling point is 100, and that means at room temperature it is. Room temperature is about 20 or 25. It has not yet reached melting point yet, so it is a solid. Formic acid has a melting point of 8, that is below room temperature. That means at room temperature it has already melted. It hasn't boiled yet, so it is a liquid. Palmitic acid, the melting point is 63 degrees centigrade. That is above room temperature, and that means it is still a solid at room temperature. Are we okay with all of these? This chapter is easy and the questions should be easy. The change of state when water vapor changes into liquid is which one? Water vapor into liquid, that is condensation. From gas to liquid, condensation. Describe what happens when water vapor cools to form liquid water. Your answer should include the change in energy, arrangement, and movement. So this is a different version of the question that is asking about what happens when you change from one state to another. So we're changing from what? From gas to liquid. What happens to the energy? Gas to liquid, we lose kinetic energy. The particles move nearer to each other, and the particles are moving more slowly because we're talking about from gas to liquid. Okay, did you get the right answers for all of this? So, this is another question on the open-ended tube that has ammonia on one end and hydrochloric acid on the other. And he's saying complete the chemical equation for this reaction. We did chemical formulas. You should have done chemical formulas last year, and we're going to revise it again this year. But for now, let us say that ammonium chloride is NH4Cl. Now, draw a circle around each of the two state symbols that could be included in this chemical equation. Do you know what form of state is ammonia? You should realize that ammonia was a gas. Hydrogen chloride, when it moves, it is also a gas, and ammonium chloride is a solid. When it forms ammonium chloride is a solid. The others are gases. Ammonia is moving in the form of a gas, and hydrogen chloride is moving in the form of a gas. So these are the state symbols. The diagram shows arrangement of molecules in states of water, and he's saying complete the diagram to show how the molecules of water are arranged in the solid state. The solid, you should have a diagram that has particles, all of them touching each other and arranged in regular rows. You can fill the whole box, or you can just put part of the box, but they should be all touching in regular rows. Which row of the table correctly describes the arrangement and movement of molecules of water in solid? Solid, you should realize that the arrangement is what? Regular or random? In solid, the arrangement is regular and the movement is vibrating. So that's your answer. Which word describes water changing from a liquid to a solid? From a liquid to a solid, what is that? That's freezing. Okay. Give the word used to describe the change of state represented by this equation. Remember that when we write an equation, the S represents solid, If it's an L, it will represent liquid, and if it's a G, it represents gas. So this equation is showing me water changing from the solid state to the gas state. From solid to gas is called what? What was the change directly from solid to gas? It was sublimation. Water is the name used for H2O liquid. Now give the two names for H2O gas. You should realize that water in the form of a gas may be referred to as water vapor or steam. The diagram shows arrangement of particles in the three states of matter, but they're not arranged in a particular order. So you have to first of all figure out what is X and what is Y and what is Z. Do you realize that X is what? X is a gas and Y is liquid, and Z, the regular rows close packed, that's a solid. So he's saying use these letters to give the starting and finishing states of matter. If we're talking about ice to water, you should realize that ice is what? Ice is the solid state of water, and water as a water, it's a liquid. So we're changing from solid to liquid, and that means we're changing from Z to Y. Solid iodine to iodine gas. So solid to gas, we said solid to gas, that would be from Z to X. Molten, the word molten means liquid. Molten iron, that means that they have heated the iron until it has become a liquid. So we're changing from liquid to solid. Liquid to solid, that is Y to Z. Now, if I have ethene to polyethene, we haven't done organic yet, but ethene is a gas and polyethene is a polymer, and that is a solid. Polymers are what we call plastics. So we're changing from gas to solid, gas to solid, that is X to Z. Do we understand that? Which of these changes takes place when solid iodine is heated to form iodine gas? So we're changing from solid to gas again. Solid to gas is sublimation. Are we all okay with this? Okay. The diagram shows apparatus that can be used to measure the melting point of a solid. The solid is placed in a small tube. The small tube is then put into a liquid contained in a beaker. The liquid is gently heated, and the temperature at which solid Q melts is recorded. So basically, this is the apparatus we are using to determine the melting point of something. So solid Q, he found that solid Q melts at 140. So explain why water is not a suitable liquid to use in this experiment. Of course, if I'm trying to find something, the melting point of something that melts at 140, I can't use water. Why? Water boils at 100 degrees, and that is lower than the melting point of solid Q. So I will heat the water until it boils. I will never reach 140 degrees. Suggests why the liquid in the beaker needs to be stirred constantly. When we're heating something and trying to measure its temperature, we should stir, and as the diagram shows, he has a stirrer in there. We should stir in order to do what? In order to distribute the heat equally in the liquid. So when you are measuring the temperature of part of the liquid, that is the same as temperature in all parts of the liquid. So this is to distribute the heat equally in the liquid. Okay. In that case, we have done the questions on the first chapter, and next lesson we will do the explanation for the next chapter, which is talking about experimental techniques. Thank you for being with me.